everyone, and welcome to our 2021 Take 30 series. We've got a nice kickoff for the year with a panel of people talking about analytics modernization and data prep. We'll introduce everyone in detail a little ways down the line, but we're going to talk about Ironside and Trifacta's background, some commonly asked questions, and then open it up for any questions that you might have. So if you have questions, there's a questions box you can type them into. Please do that at any time, and we'll answer as many as we can. This is the first Take 30 of 2021, talking about analytics modernization and how we can accelerate it with data prep. We're going to be going to our Thursday 11 a.m. time next week, talking about executive dashboards and UX design, moving on to enterprise reporting, and then getting started with AI. And as usual, we sort of alternate between BI expert, data scientist, and data advisor. So we look forward to seeing you on those Take 30s as well. So Ironside's goal is to help you make better decisions about your business using your data. We're good at modeling, structuring your data, putting it in the right place, and making sure that you're doing what you need to do to get value out of it. And so we have a variety of capabilities, from strategic advisory to design, which includes UX design and data modeling, to building out analytics, ML models, data warehouses, deploying them, making sure that they're well governed, which we'll be talking about today. And that could include master data management, as well as things like stewardship and lineage and that kind of governance. And then we also help you manage it. We can actually host your software. We can administer things, just so you don't have to worry about some of these specialized tools. So really sort of all the way around the circle, we can help you in a variety of areas to improve your analytics. And so that's who Ironside is. I want to pass it over to Monte Montemayor to talk a bit about Trifacta, and then we'll be getting to some questions. Monty?
Thanks, Jeff. I really appreciate it. Good morning, everybody. My name is Monty with Trifacta, and I run the systems integration companies for Trifacta. Ironside is one of our premier partners, really a go-to partner that really understands the full modern data analytics stack. Very rich background in terms of what they bring to the table, as well as their customer success. I'm going to run through a few brief slides about Trifacta, mainly just to position what we do in the space that we play in. And then I'll be moderating our panel discussion. So we have a couple of questions that are pretty common that we're going to tee up. And then also, I want to highly encourage you to ask any question you have. We have an amazing set of panelists today. We have representation directly from AWS, a solution architect, who I'll introduce in a few minutes. And if you have any questions, no such thing as a dumb question. So now's the time to ask, because you have a very highly skilled set of people on the call today. So Jeff, next slide. Let me just quickly run through these. So we've all heard this phrase, data is the new oil. I always thought that was a kind of a funny stage, because data isn't necessarily inherently valuable if it's in the ground and unrefined. And it turns out that data is a very prevalent thing in our modern business, but the truth is that IDC tells us that only 1% of the data actually gets analyzed. So the real question is what happens to the other 99% of the data? Is it useless? Is it even valuable? How can we even think about it in terms of something as valuable as oil if 99% of it never even gets analyzed? So I would propose to you that there's a lot of value there inside of your organization as it exists now that's unrealized. So next slide, Jeff. And the other big trend we're seeing here, and this is actually one of the specialities of AWS, is you hear that AI is the new electricity. And I think it's a play on data is the new oil. But here's the thing. AI is a very, very powerful technology and a very powerful concept. But what happens if your data is dirty? And what happens if your data is not in a state and in a format that can really be utilized as a valuable asset? So there's some really, really cool technology in the world today. And every single one of those technologies is predicated on having clean data, having clean answer sets, having a clean data lake that actually will drive the value of your data. And next slide. So here's how we kind of sort of see the world. On the left-hand side of the screen, you see the data platforms. And I like to think about these as, these are where data gets created. And in our world today, data gets created in databases and source systems like Salesforce.com or Mercado, or ServiceNow, or IoT sensors, or cameras at intersections, or applications, or mobile devices. So we live in a world where data is just pouring into our organizations. Well, on the other side of the spectrum, we want to do something with that data, right? We want to throw it into a Tableau dashboard. We want to feed it into an AI ML system. We want to create a data and analytics reporting. We want to really, really drive value out of our data. So those are the two ends of the spectrums. But what happens in the middle? What happens in the middle is the data has to be cleaned. It has to be prepared. There has to be value that's added to that data. Oftentimes, you need external data sets to augment your data. And in fact, it turns out that that's about 80% of the time of the data analytics project. So although you see the reporting in the dashboard and they're really cool and interesting and interactive and colorful and things like that, that's not really where the heavy lifting happens in a data analytics project. It's really all the stuff in the middle. Next slide. So what Trifacta does is Trifacta is in the business of helping end users actually shape their data. Back in the old days, you needed to have very highly specialized skills for people to actually clean your data. You actually needed people to write code, write scripts, write SQL commands and things like that. And then came the modern ETL vendors, which was a great step forward. But the problem with ETL is that it still is primarily an IT function. Well, now you have Trifacta. So what Trifacta does is we sort of sit in the middle of the modern data analytics stack. And one of the things I appreciate about Trifacta is we're really good at doing one thing, which is helping organizations, end users, citizen data scientists, data analysts, business analysts, shape their data for high value usage. So for example, we have partnering relationships with the catalog vendors from Relation, Cleaver, and IBM. We also have relationships with the BI companies like Power BI and Tableau and QlikView and Looker. Same thing with the data scientist stack and the ingestion stacks. We work with all the modern data cloud architectures. Obviously, AWS is one of our key go-to data cloud. We run as a native service on AWS. We run in EMR, and we also access S3 buckets natively. And then we also work with all the modern data warehouse stacks like Redshift and Snowflake and so forth. So Trifacta sits right in the middle of your data analytics stack. Next. And there's Trifacta. Next. So Trifacta has been around for a few years now, and in fact, we feel that we were one of the inventors of the modern data analytics category to begin with. And over the last several years, Trifacta has been #1 in terms of our recognition by Gartner and Ovum and Dresner and Forrester. And you can see that even most recently in the G2, which is a crowdsourcing organization, rates Trifacta as the #1 data preparation tool. So we're kind of a young company from that perspective, but on the other hand, we are, for example, we're the largest data preparation solution in the AWS ecosystem. So we're very, very good at what we do, and that's why we work with companies like Ironside to really bring a lot of value to our customers. Next one. So what I want to do now is I actually want to introduce our panel. So Jeff, can you go to our panel slide so I can introduce the players?
You bet.
And let me just take a couple minutes to introduce who's going to be on our panel, and then I'm going to kind of open it up, and then we'll kind of have an interactive discussion here. So first, I want to introduce Jeff Spear. He's the one that kicked off our meeting today, and he's a data advisor. He's been at Ironsides for over 10 years, and he's really great at taking a sea of unrefined data and then turning it into useful assets for companies. And he really specializes in data architecture and integration. And next we have John Fellner, who is a BI expert. He's been in the data analytics industry for over 20 years. He's been saying that for 10 years, so we can all do the math there, but he's been around for a while. His forte is to create systems that are really easy to use for end users. And he has a knack for reducing complexity from end users. He's a big sports fan, especially with basketball and baseball. loves live music and can't wait for this COVID nonsense to get behind us so we can start to attend live music again. Next, we have Dr. Pam Askar. And Dr. Pam is the practice director of the data scientists group at Ironside. And she specializes in quantitative research and predictive modeling, and actually became a data scientist in an unusual path, different career path than we often see. She actually has a PhD and she studied developmental psychology. And developmental psychology actually requires doing a lot of modeling to model change over time. And it's actually a very data-driven function. So in the process of her doing that kind of work and that kind of research, she fell in love with this aspect of creating predictive models and doing advanced analytics. And then over 10 years ago, she just made the jump entirely to go full-time as a data scientist. Next, we have Subodh Kumar, and he's with AWS. So thank you, Subodh, for being on the panel today. Really appreciate it. He's the head of the solution architect team at AWS for artificial intelligence, machine learning, IoT, and high-performance computing. He's been in the technology industry for a long time, of over 15 years. And actually, Subodh actually holds a couple of patents in hardware and software design. So all that to say, we have a pretty bright team of panelists for you today. And so we are really encouraging you to ask some really good questions. And I think what we'll do now, if we're ready, everybody, is let me begin the process. And I will start to ask a couple of questions. And then if you will, in the chat window, ask more questions. And between me and the team, we'll do our best to answer all these questions. Does it sound good? Ready to go. Okay, the first question is for Jeff, who's a data advisor. And so Jeff, we all know that we've had so many different data formats in the world today. If we think back to just a couple of years ago, it seems like we are now faced with data formats that didn't even exist a couple of years ago. If you think about when Microsoft Excel was introduced to the world, I think it was 1987. If you think about the amount of data in the world then, and if you think about the data formats then, people still use Excel to try to shape their data. And it really is a very powerful tool, just not designed to address today's challenges. So how do you do that, Jeff? When you go into a new company, how do you begin the process of entangling all this complicated data?
Yeah, that's a common problem that we face, Monty. And I think you're exactly right that there's just so many different types of data now. It can really be a challenge. And the thing that people think about, it's on everyone's tongue, is having a data lake. And so everyone says, okay, great, let's have a data lake and put everything in, which is generally speaking the right answer. But that's really just the starting point, because a data lake is very good for ingesting data, but it's not really designed be the best way to get data out. And so what we promote is you absolutely want to have all your data in one place, but then you need sort of a flexible way to move data out as people come up with new insights or new requests or new needs. And so, of course, there will be, as you mentioned before, there will be ETL on the IT side where there's stuff where we know we need to move stuff around. Let's do that on a regular basis. But we need more flexible tooling to be able to, ingest, join, integrate, and cleanse data, once it hits the lake. So understanding sort of what that need is, what kinds of data an individual organization is dealing with, and then figuring out not only the best way to store it, but the best way to manipulate it.
Got it. It seems to me that whole process that you explained really is the challenge in a data analytics project, is to figure out the type of data lake you need, make it accessible so the end user can really drive value out of it. I think in the old days, we used to always call IT, right? If I needed a report, if I needed a dashboard, if I needed a database, I'll pick up the phone and call IT. And as we all know, that takes a long time. IT is extremely busy. They seem to have the weight of the world on their shoulders. And it created a sense of frustrations on the part of the end users, right? Because they wanted data, they wanted it quickly, they wanted to kind of get on with their job, but they had to wait. And it became a very painful iterative process. But that actually leads me to the next question that I have really for you, Jeff, is, these days we hear about these so-called modern data analytics stack, right? So people talk about these cloud tools, they talk about this modern stack. Well, what is it? And why do we even need it? Like, what's wrong with the old stack? Can you comment on that?
Yeah, so you mentioned Excel as sort of the ultimate old stack. And Excel is really good at doing certain types of analysis and sort of getting to the point of realizing insight. But what it's exceedingly bad at is making that repeatable and making that something that can be shared across an organization. So we go to places again and again and we see they've got all these Excel files and people are spending days or weeks refreshing them periodically because that's where the insights are. And so these people who could be discovering new things are stuck maintaining old things. And so, that's the problem. That's why we need a change. And like you said, IT gets that stuff done, but it's more heavyweight. You use that for sort of known high value data. And with all the different data that's out there, and then the different tools and skill sets that we see, you just need different ways for people to get at data, whether they're data scientists or power users or business analysts. They all have different ways they want to get at data. But when they're done doing that, you want to make sure that you can understand what they did, and if what they did is valuable, that you can easily reproduce it. And that's really where that stack comes in.
Yeah, you brought up a really good point. I think the auditability is really key, especially in certain industries. If we have pharmaceutical or highly regulated industries, that auditability of that data is paramount. I can't imagine picking a data tool that didn't have built-in auditability.
Yeah, precisely. And that's, it's we like Trifacta because it's repeatable, it's auditable, but it's also very visual in terms of seeing what's going on with data. And so you can very quickly identify problems and get to the point of bringing things together and getting to your insight.
So Jeff, John, actually, I'd like you to kind of pick up where Jeff left off. And we're also dealing with another phenomena, which is really the volume of the data that we're seeing in our world today. I can't even fathom the amount of data in terms of size. When we hear about the sizes of the data sets, it kind of boggles the mind. It's really hard to get your arms around it. So kind of what can you say about the approach that's needed in a modern data architecture regarding the volume of it and even the structure?
Yeah, that's a big challenge, Monty. Back in the day, there were a lot fewer structures. The volume was a lot lower. Today, everything's in different places, and the BI team is usually one of the first places people come to after the business to try to distill through all that. So that is definitely a big challenge. I would say, traditionally we always love to have these perfectly modeled star schemas to do our reporting off of. That's no longer a reality. That's more something that you strive for the more structured reporting, but people need quicker answers and people need to sift through that data, and they need a tool to be able to do that. There's a lot more noise than ever too, and sifting through that without some assistance is really tough. So having a way to filter through noise and get outliers out of the data before you start to make sense of it, I think is a big part of what a tool like Trifacta can do.
What's interesting is you reminded me of something, John, is I used to work for a large software company in Washington State, and we would often sit around, the leaders of our organization would sit around for about the first 15 or 20 minutes of a meeting, figuring out who had the single version of the truth, because we all were faced with Excel files as business users, which is true of today's business users. They need answers and they need them yesterday, right? So what we do is we basically pull our own queries as best we could. We'd show up to a meeting with our report on our computer, and then we'd argue about whose report was correct. And that's a gigantic, enormous impact on productivity. So it seems to me that as we move forward, because we have so much more data to contend with and data types, we simply need better structures and better approaches to service our end users and our business analysts. So John, that actually brings me to another question I kind of wanted to run by you is, you're a BI expert and an engagement manager, so you're often one of the first people inside of a company to start to really begin to solve their problem. And as companies are faced with net new data that's just raw and ugly and messy and complicated, how do you do that? Like, what do you do to begin to the process to untangle the data?
Yeah, the first thing we want to do is take a full inventory of all the source systems that are involved in the reporting. And a lot of times people don't even know what all of them are at that point. They have their business questions. We try to pull information from those business questions. but we have to start deep diving into profiling the data, right? And I think of a use case where people traditionally had used tools like BI tools to try to do some of their data profiling to really expose some of the obstacles, the things under the iceberg, right? That you may not see just in a raw spreadsheet or in their source system. A lot of times people think their data is clean and it's not, or that it's complete and it's really not, and it's going to cause issues down the road. So we end up using the BI tool sort of in an improper manner. But what I want to know is, how well is this data structured, if it is at all? How can I use it without a lot of wrangling? Typically the answer is no these days, right? And then what efforts involved really to get it to look good enough to consume in a reporting application or a dashboard? What does my audience expect? So a lot of what do I have in front of me and what does my audience expect? And then how do I get there? How do I cleanse it or clean it or go back to, the ETL folks to help get it in a better structure for me? So, manual files may work great for a rapid kind of POC type thing, but it's not sustainable for a production application. So, we may be going in to do a POC, but there's going to be a lot more work later on if we think we can, you can't just turn a spreadsheet into a executive dashboard, for example. So there's a lot of work that needs to go on in discovery, and having the tools to help you do that is key.
It's funny. A question just came into the chat room, which goes along with what you're saying, and this question is for either you or Jeff. And the question is how do you begin to have that conversation with leadership to invest in a tool, frankly, like Trifacta, a tool, frankly, like AWS, a tool, frankly, like Tableau or Power BI? What's that like when sometimes executives may not see the value of it? They want the report and they want the data, but having the conversation to have them make an investment is sometimes difficult. How do you have that conversation?
The executives are the ones with the money, so that's the right audience. But you do need to show them. Showing is believing. So if you can do some type of a proof of concept up front with a short window and a rapid development cycle, I think that works. That's usually people get excited when they start to see results, and that's usually what we would lead with, something like a proof of concept.
It sounds like a big piece of this is painting a vision, showing the ROI, kind of doing vision casting with the executive team so they can sort of see what's possible, right? Sort of see the value of their unlocked data.
Yeah.
Monte, if I could add.
Yes.
So one part that we always have our discussions on with the execs is how much time does it take from getting the data to getting the inference? Basically, the lag between capturing of data and the decision-making capability. That time window has been shrinking over the last few years, or last 10 years, but shrinking significantly over the last few years. And that immediately lifts the reason for you need to have tools and automation in place. People doing it is just not going to work anymore.
That's a great point. And that actually leads me to a question I was thinking about for Dr. Pam. So Dr. Pam is the data scientist on our panel today. And the data scientist people in the organizations are the true rock stars. I'm not sure, Pam, that you look in the mirror every day and say, I'm a rock star, but you are, because rock stars are rare and they're extremely valuable to our society. And I do know that if you think about all the different professions in the data analytics scheme, the data scientist community is a small community actually, and extremely powerful. And I'd love to know your thoughts on kind of how has that role changed? Basically what Subodh was talking about, of how the time is being compressed and the requirement is being compressed. How has your role changed over the last 10 years since you've been doing this?
Yeah, that's a good question. And I'm going to call myself a rock star next time I look in the mirror.
You should.
It is a more rare skill set, right? And so the time is valuable. And traditionally, data science, and when I say traditional, some organizations are still working like this. Even myself, 4 or 5 years ago, were working like this. But traditionally, data science work is very siloed, and they're doing every end of the work, from working with raw, very unstructured data and various data sources, manipulating that, wrangling it, cleaning it, preparing it for machine learning, to the machine learning work, right? So everything from raw data to finished AI product. is on the data scientists, and they work in this silo on that. But the work from raw data to get to the beginning of machine learning can be 70 or 80% of a data scientist's work, right? And what's changing is that tools like Trifacta allow me to make this a team effort, and I don't have to work in a silo, and I can bring in an analyst who doesn't know Python or any other coding skill, and under my guidance do all that preparation and get it ready for me. An added benefit is that people get really excited to work on data science, right? So they get engaged, they get excited, they see other skills that they can develop and grow. And the key benefit is that you take these rare resources and all their time being sunk into the data wrangling now, that unburdens them, right? So now these models that they might have in production, they can go check on, retrain, monitor them, get models into production, look at more use cases. So you can take the reason that they're specialized, the rare skill sets, and use more of that, right? By making this more of a team effort and getting more people involved to do the work that they can hand off. So it's changed a lot.
That's really interesting. I never thought about that aspect of actually broadening the scope of who's involved in the data science function. That's a really interesting thing. Well, time for some real talk now then. So we've heard about the rise of the so-called citizen data scientists, right? We saw the rise of shadow IT, and that basically made IT really uncomfortable in a lot of ways. I'm curious your thoughts on the so-called citizen data scientist. Real talk, friend or foe?
Yeah, no ego here. I really think more the merrier. I mean, I was just talking about making this a team sport, and I really enjoy that. And I like working, especially with younger people who are getting interested and involved, and they can work on these projects and they can level up and get new skills. A lot more people are learning about machine learning, how to apply it, and there's a lot of technology that makes it easier and easier. So I'm all for that. I think there's plenty of data science work out there. I would, however, caution that doing that, going off solo on your own may be a mistake, and that doing it without the guidance of a properly trained data scientist can lead you astray. It's really one of those fields where you don't know what you don't know, and it can be very easy to make a mistake, especially a lot of the tools, they accelerate everything, but it makes it almost too easy, right, to fit a model. So I would say, under guidance, I have no issue with them. I'd say, friend, let's broaden the playing field. Let's bring in more people. We can accelerate and get more work done. But let's just be careful about, running solo without some guidance.
Great point. The last thing you want is a Wild West scenario to have, because then you're going to have the situation that we were faced with at the software company, where everybody has a different version of the truth, and then it becomes a real hairball. You may have created a bigger problem, right? Yeah. So the answer is that you're all for it, but you want to make sure that there's some guidance and some guardrails in place to make sure it doesn't get out of hand.
Yeah.
Great. Subodh, I have a question for you about AWS. So AWS is definitely all the rage right now, with such a high percentage of customers going over to AWS. I'm curious about your thoughts around what is now possible using an AWS stack for data and analytics and data preparation that just wasn't available a couple of years ago. It seems like there used to be industries that we thought were tabooed. Like financial service will never go to AWS. Government will never go to AWS, and both of those are full steam ahead now, right?
Yep, that's very true. Actually, a bit of context of why these companies went to AWS, but more so why data science is driving a whole lot of this is, first is, from a context perspective, we had initially we had transaction system, then we had a lot of data, we had data warehouses. We are at a point where business almost needs inferences every time to make a decision. Almost all decisions are data-driven decisions and have to be that way. Going forward, it'll probably be all the more important. We saw that in COVID. I mean, the vaccine creation, we have probably not seen so many companies doing vaccine investigation at a time and coming up with a vaccine in a matter of a year. When we were talking about it initially, it's like, okay, vaccine creation usually takes about 8 to 10 years. By the time we'll have so many million people die. Well, things have changed. The compute structure, the overall number of tool sets that you have available, those things drive it. So bringing it back to why and how cloud enables it. If you really look at two things that one is Dr. Pam said about citizen data scientists, and second, the number of data scientists that are available, very few. And there'll always be a shortage of that. These are PhDs. These are hardcore people who have learned statistics to the core, who have learned programming to a great degree. We have learned distributed computing, all those pieces. Very, very rare. We call them unicorns in our company, by the way. So rockstar, unicorn, you get both the titles, man. With that in mind, where do you want them to spend their time? And the next part is, and this I learned from my last two companies, where creation of data lake actually took much longer than they anticipated, not because they didn't have money, very large banks, but because it requires a lot of steps. First of all, capturing data, preparing data, as you said, and then by the time you are there, things have progressed onto a much further. When deep learning came in, the first thing that started pushing it is a large amount of data and large amount of compute. How many companies can start putting GPUs and FPGAs on their prem? And I'm not saying companies cannot, but how many? If you want inference to be in everybody's hands, you need to make sure that all these compute is in everybody's hands. And that is possible if you spend a lot of money and spend a lot of time. But is that what your business is? Do you want to get into the business of inferencing, or do you want to get into the business of delayed infrastructure put in, and then realizing that the amount of compute that you need requires FPGA or something else that you don't have at that point in time? I think the value that comes from this infrastructure and the speed at which you can get to the infrastructure is amazing. When somebody like Pam is doing building an algorithm and suddenly realized, and I'll give you an example of high performance compute in which massive car designs are happening, they realize that they can put a whole bunch of infrastructure, but suddenly it's like, oh, this will only scale vertically. Well, now let's go find better chipset. Well, how much time will it take to bring the chipset in? These things being available is like you are an artist with a whole bunch of toolkit in your hand. You want to turn around and try another toolkit or another toolkit, you have it available, right? So that's part one of that. Part two, sorry, I'm taking longer, but there's so much to talk about. Part two is the citizen data scientist part. The algorithms that data scientists create, the only way to bring it to the business is reuse those algorithms as many times as possible. And you can do that by building, I'll just go technical, API layers on that. So what Pam and her team builds, if you make it consumable by developers, forget about developers, by business analysts who can just pull it and then start integrating that in their application, that's the way to get the real machine learning capability into every single business and move really forward. So with these capabilities, I think cloud enables a lot of companies with less amount of money, large amount of money, either because they have a lot of tool sets available, or they have agilities available, or just because there's a whole bunch of APIs and models that people are creating, smart data scientists are creating, that can be used for business inferences.
Got it. That's great. So basically scale, agility, speed, flexibility, things like that are now possible. Sure. I never thought about until you mentioned it. You're basically saying that there's a vertical elasticity aspect of it as well as horizontal. So if something new comes out technology-wise, you're going to plug that in and then everybody's going to benefit, as opposed to a particular company saying, well, we got to update our servers now. I do come from a generation where selling software involved standing up physical hardware and buying, Microsoft NT licenses and things like that, and then hiring administrators and DBAs and all that stuff. And then that is time, cost, and loss of flexibility. And also what you said earlier, by the time you get the environment running, the business users are asking a different question entirely, right? They're often something else that's really, really big here.
Very true.
So that actually does bring me to a question I have for Jeff and John. And Jeff, why don't you take this first? But the question is, sure. As you think about some software vendors that offer a full stack solution, like they basically do everything. They do the warehousing, they do the data scientist elements, they do the data preparation. You have these certain vendors that offer everything in one-stop shop. And then you have other situations where you have a combination of best-of-breed applications like Trifacta with Redshift, things like that. Can you comment on maybe the pros and cons of using a single stack vendor versus using a best of breed approach?
Yeah, I think the challenge we see, we talked about sort of just a proliferation of data sources and skill sets and tool sets, and so the best of breed is usually something that fits better to that. A single sort of vertical stack is great sort of in a very isolated use case where the person using it, that's exactly what they want. But often what we see now is with any piece of data, there's lots of different groups using it, and so it's unlikely that they're all going to want to use the same tool set. And so going with best of breed, because best of breed, it may be a different specific stack depending on what people are doing. So Pam may be off writing Python while someone else is going to use Trifacta to do similar kind of work or different kind of work. And so it's also why AWS is so popular, because there's so many different services, so many different ways to solve things depending on how you want to come at it, what your requirements are, and what your goals are. So we definitely see the best of breed option as something that is far more common and far more successful and far more likely to succeed into the future, because as things change, as needs evolve, as technology evolves, it's much easier to fit new solutions into that than it is into a single vertical.
Agree.
Also, I think that there used to be a day when large software companies had proprietary solutions that didn't talk to anything else, right? That's no longer the case. So essentially, we've had Trifacta customers using our software in ways that we never even envisioned, because they're talking to a particular system that we did not know about, but they exported a CSV file and it works wonderfully. That actually does lead me to another question. Actually, this is for Dr. Pam and also Subodh. It has to do with, what are some of the common problems you're seeing when you're trying to prepare data for an ML model or an ML or AI model? It seems to me that that is such a technical thing to do to get it right. And I'm not a data scientist, so I don't know the iteration levels, but what are some things to think about and how do you do that?
Yeah, well, the first part is extracting the data, right? You've got to get the features and aggregate it to the right level and make sure that they're at the right level that you're going to be modeling. But then it's things like missing data, skewed distributions, outliers. All of these can really throw your model off. And so you have to treat those, and you have ways to treat them, but you need to be visualizing the data at the same time. So being able to have a tool where you can actually see those outliers and see that distribution and make an adjustment and then see the result is very helpful. And also, like I said, if you're having an analyst do that kind of work, giving them that ability to visualize the data, to see it, and to make some decisions on it is helpful.
Great. Subodh, do you want to comment real quick on that?
Yeah, actually, Dr. Pam said all the things. I wanted to add one. This actually happens a lot in in the anomaly detection space. Fraud, we're working on a fraud case, and it's like, okay, you don't have enough fraud data, you don't want enough fraud data, right? If you have too much fraud data, then that's a problem with your company. So you have a very much of a data skew, as Dr. Pam said. So how do you balance those? Do you generate more data? If you have to do that, what do you do? I mean, different algorithms, things like that, or not? Then how do you take out the biases off the data so that you have correct pictures? That actually is coming up a lot. I'm not here to talk about the product, but just a product called Clarify came in because of the reasons like those. Not exactly, but it's very similar, where you have data biases in the data, where you have biases in your model. Identifying those, extracting those ahead of time is extremely important. I mean, you can do it later on I mean, in retrospect, which is fine, but something where you can visualize the data to see those patterns is extremely valuable before your model goes any further.
Got it.
That is a very common problem and a difficult one.
Hey, everybody, I just realized that I am over time. I was so engrossed in this conversation. I wish we could go a lot longer, but I do apologize for running late. I did not watch the clock adequately. I'd like to turn it back over to Jeff. And before I do so, I want to thank everybody for your great questions you've teed up, and really thank our panelists. Fantastic insight. And like I said, I could probably do this for another couple hours. This is a great conversation. Jeff?
Thanks. Yeah, it's always good with a lot of good questions. It's always fun to come on and answer them. So thanks everyone for listening in. I do want to say, Debbie asked me to say this and I forgot at the beginning, but there should be a link in the chat to sign up for our ongoing series, which again, we've got them coming up next Thursday at 11 a.m. and then Thursdays after that. So please hope to hear from everyone and see them on the webinars going forward. So, and I wanted to say thank you to everybody for being on the panel. A lot of great questions, Monty, a lot of great answers, everybody. So thanks to everyone and have a great day.
Thank you.
Cheers. Bye-bye.
Yes, bye-bye.